All right, section 7.1, find the side length of the square, label your answer. This question right here is why, when you see this symbol, you call it a square root. Finding the square root of a number is the exact opposite or inverse of squaring a number. The reason when we raise something to the second power, we say we're squaring it, is because we're finding the area of a square that has that side length. So if I told you that the area of that square is 324, that means they took a number, times it by itself to get 324. We need to know what that number was. Length times width in a square is the same. So I need to know what number times itself is 324. You may not know, or maybe you do, if you've started looking over your, or maybe you had this problem in your iExcel from Friday, but if you don't know, that's where the square root button comes in. So the square root button on our calculator, we should know where it's at. If you have a calculator like this one, you're gonna hit, oops, don't drop it. You're gonna hit second function and then your x squared symbol. Some of you guys have calculators that have a square root button already. You don't need to hit the second function button. Can someone tell me what the square root of 324 is? Christian? 18. So each of these side lengths are 18 centimeters. 18 times 18 is how we get 324. So you could say that the root of that square, its square root, is 18. So the side length or the root of that square is 18. So get into our vocab for this first section. When you multiply a number by itself, you are squaring that number. So you square the number. So 4 squared equals 4 times 4, which equals 16. You guys know that. That's not what today's lesson's over. Today's lesson is going to focus more on the inverse of that, square rooting a number. To undo this, you take the square root. The square root of 16 is the square root of 4 squared, which is 4. So squaring and square rooting are inverses. Oftentimes, if I ask students that aren't familiar with square roots, if I ask them what the opposite of squaring a number is, a lot of them say divide by 2. Have you heard someone say that before? I get it every year. I say, what's the opposite of squaring a number? They say divide by 2. Because in their mind, they think timesing a number by itself, dividing by 2 would undo that. Dividing by 2 does not undo it. Square rooting tells you what two numbers, so it's the same number, multiplied to give you, in this case, 324. So the square root of a number is a number that, when multiplied by itself, equals that given number. The square root symbol is actually called a radical sign. So in a moment ago, or when I was talking about simplifying radicals or writing in radical form, that's something we're actually going to talk about. It's a 9th grade standard that I'm going to teach you guys how to do this year. That way your teachers don't have to reteach it to you next year, because they're going to reteach it in the same unit you're doing at Pythagorean theorem. So I might as well just show you, when you're using Pythagorean theorem, how you leave your answer in radical form. The number under the square root symbol is called the radicand. Okay, and the way I would read this is the square root of 100. And what is the square root of 100? Lizzie? It's 10. Yeah, 10 times 10. Every positive number has a positive and a negative square root. That's because when I square a number, it's always going to give me a positive answer, whether the number I'm squaring is positive 4, which gives me 16, or even if I'm squaring negative 4, I still get 16, because a negative times a negative is still a positive. So if I ask you for the square root of 16, I actually have 2 answers. You could say it's 4, or you could also say it's negative 4. So how do I know which one I'm looking for? Well, fortunately, they're going to be very specific. Now, I say that because the reason I say positive is up here for 2 reasons. First of all, 0 is not positive. 0 is neutral. The square root of 0 only has 1 square root. It's 0. Every other positive number has 2. Even if it's not a perfect square, it still has 2. We'll talk about in a moment what happens when you square root a negative number. Why don't you try doing that? You know the square root of 64 is 8. Try doing the square root of negative 64. Owen, what's it say? What's the square root of negative 64? You haven't tried typing in your calculator, have you? Sky, what do you get? It says error. says, dummy, what are you doing? No, that's because it doesn't exist. And we'll talk about in a moment why not. Okay, but you can only square root positive numbers or 0. So why don't we just say that you cannot square root negative numbers? We'll be safe saying that. Now, that's not to say that I couldn't get a negative answer if I'm asking for the negative square root. So it's about where the negative is located. If you see a square root symbol, like you see square root 16 here, and there's nothing in front of the symbol, just assume that they're looking for the positive square root of 16, which is 4. If you see a negative in front of the square root, assume they're looking for the negative square root of 16, which is -4, because -4 times -4 is still 16. If you see a plus and a minus symbol, they're looking for both positive and negative. So you could write 4 and -4, or you can do what they did and just put positive -4. This means 2 numbers, positive and -4. So there's 2 answers there. Okay? So why can't you have the negative underneath the square root? When you multiply by a number by itself, the product cannot be negative. So although the negative outside the square root means I'm taking the square root of 16 and then I'm just looking for the negative version, if you put the negative inside the square root, all of a sudden we get error as our answer. And that's because that number is not real. Can you think of a number that when you times it by itself gives you -16? Does 4 times 4 give you -16? Does -4 times -4 give you -16? No. The only way I can get 16 is if I multiply 4 and -4. And are you squaring a number if you times the number by its inverse? That's not what it means to square. So the square root symbol can never be underneath the square root sign. I said that wrong. The negative symbol can never be underneath the square root sign. It can be on the outside of it, can't be on the inside of it. There is no square root of -16. There is no number that exists that when you times it by itself would give you -16. Now, when you get into your high school classes, we actually do have an answer for this. Do you guys know what it is? What is the square root of -16? Plus or minus 4i. I'll just write 4i. The I stands for imaginary. If a number is not real, then I guess it's imaginary, like some of your friends. Just kidding. That hit kind of hard some of you. Okay, I know, right? I mean, I wasn't looking right at you, but in a sense I was talking right to you. Okay. So when you get into high school, we actually have a reason that we would want to use these non-existent numbers, but for our purposes this year, we are never going to use any of these imaginary numbers. So you can just remember that if I ever ask you to take the square root of a negative number, it doesn't exist. Even when you're in high school and you're doing pre-calculus or whenever you use these, it still doesn't exist. You can think of it existing, but it technically does not. All right, so let's find the square root. If I'm looking for the square root of 25 and there's nothing in front of the symbol, how should I write this answer? Carson? 5. Carson knows 25 is a perfect square. She's got 1 of her 25. I'm just joking. I'm just making a point because you guys already know some of these, don't you? I say, memorize your first 25 perfect squares. It's not going to be 1 through 12 or 1 through 15 you're focusing on. It's going to be 23 squared or 21 squared or 24 squared. That's where people get slipped up is those in the 20s. What about negative square root 1? Maddox? -1. Notice the negative is outside the square root symbol. So they're asking for the negative version of square root 1. So still square root 1, that's still legal. They want the negative version of it. What about the next one? Deegan, square root of 9, negative square root of 9/16. That's exactly right. So the interesting thing is when you're square rooting a fraction, it's like square rooting the top of the fraction and square rooting the bottom of the fraction. And so I don't need to try to turn 9/16 into a decimal. In fact, on your quiz Friday, it's going to say, write all your answers in fraction form. So I don't want you doing 9 divided by 16 and then getting a decimal and trying to square root that. I really just want you to square root the top and bottom. We should get negative because there's a negative in front, 3/4. What about the positive and negative answers of this next one? Oliver, what's the positive and negative version of the square root of 4/25? Okay. and negative 2/5. So you can write 2/5 and negative 2/5, or you could write 2/5 with a plus and minus sign in front of it like that. That's what I do. It's a bit less work. Now you can square root decimals. This is not one of those questions where I'd say write your answer in fraction form, but you can square root a decimal. What is the positive and negative square root of 2.25, Christian? That's right. And then example F, the square root, we can assume the positive square root of 31.36. Lucy? 5.6. We're using our calculators, right? Good. We can still use our calculator, although eventually you might get to the point where you don't need it as much because you have your perfect squares. You're starting to memorize those. Okay. So speaking of perfect squares, a perfect square is a number whose square roots are integers. I say integers because you can have a negative version of a square root. Okay. When we square root a number, typically we're going to get a long decimal that doesn't repeat and it never ends. In fact, 99% of the time, when you square root a number, that's what you get. It's only the perfect squares that when you square root them, it actually gives you a nice integer. What do we call those numbers that go on forever, never repeat, never terminate? Owen? Irrational. So the square root of any non-perfect square is irrational. And we'll talk more about those on Wednesday, because that'll be one of the things that we, in our 7.4 section. Okay. So let me give you a head start on your first 6 perfect squares. You probably don't need me for this. What's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 4 squared. 5 squared. 6 squared. Okay, just to be clear, 1, 2, 3, 4, 5, 6 are not perfect squares. 1, 4, 9, 16, 25, 36 are perfect squares. Okay, so the numbers that are in red, those are the ones you're going to need to recite to me by next Friday. So you have 10 school days, make it 9 school days because none of you are doing it today. Here's the part you might get slipped up on when you get to the 20s. Maybe it might be 19. I got a lot of people that miss 19 squared, 361. You'll know it eventually. What's 23 squared? You might have to use a calculator.
Sorry, I thought you were just asking us.
What is it, 529? Dawson, do you want to do 24 squared? 576. And somebody 25 squared? Jace? 625. That's right, 625. 625 is where you're going to stop, and you'll have your first 25. See you guys tomorrow or Wednesday? Wednesday? All right. See you guys later.
Well, I will be here Wednesday because I have power count.
Okay.
She may.
So Thursday? All right. See you guys. So the ... you need to fill that in, and I would suggest having a chart of your first 25 written out that you're kind of studying just a little bit each night. Find the 2 square roots of each perfect square. That means the positive and negative version. What are the 2 square roots of 36, Guy? That's exactly right. Deegan, the 2 square roots of 4? Good. And the 2 square roots of 121? Jacoby? That's right. You can see why I told you we're just going to fly through these notes. Even though I know it looks like we have more problems, it's because I wanted to get to eventually the order of operations problems. We might get a couple of those done today. I've done pretty good for the fact that I started like 10 minutes ago. Squaring and square rooting a positive number are inverses. Squaring and square rooting a positive number, there's the key, can't do a negative number, are inverses. In fact, taking the square root of a number is the same as raising it to the 1/2 power. Try doing that. In your calculator, you know the square root of 64 is 8. Try doing 64 to the 0.5 power. The exponent button for me is an arrow right there, but it could be different for you. What do you get when you take 64 to the 0.5 power?
You get 8.
You get 8. Yeah. Square rooting a number is the same as raising it to the half power. Tomorrow, we'll see that cube rooting a number is the same as raising it to the third power. That's what I meant when I was saying fractional exponents. Therefore, when I'm doing order of operations, all square roots, cube roots, whatever roots I'm doing, fall under the exponents category because they are fractional exponents. So please excuse my dear Aunt Sally, when you get to the exponents E, that's when you apply your square roots. So let's look at a couple of these. 5 times the square root of 36 plus 7. Is the 7 underneath the square root? It's not. So I wait till the adding portion. Let's do the exponent first. What is the square root of 36? Xander? 6. So I've got 5 times 6 plus 7. Do not times 5 to the 36, then square root. You have to square root first, then times by 5. What is 6 times 5? 30. And what's 30 plus 7? 37. Yes, I do need some work on your work papers, and you're just going to funnel your work down. 1/4 plus the square root of 18 over 2. Now, I told you before that that means you square root the top and you square root the bottom numbers. That's not going to work very well for this fraction because neither one of them are perfect squares like they were up above. But, Maddox, what do you notice about 18 halves? Yes, 18 halves is actually the same as 9. That's not a very good looking square root symbol. And Maddox, what's the square root of 9? 3. So 1/4 plus 3 is what? 3 1/4. C. We'll finish with this one. Aren't squares and square roots inverses? So what happens when you square a square root? Carson? It stays the same. So this is just going to give us 81, not 9. Because if I square root it and get 9, I got to turn around and square it again. What's 81 minus 5?
76.
76. Put up your chairs. I'll see you tomorrow.
Oh, we gotta put up our chairs.
You do. Yep, you're right.
I'm gonna write that.
Things are different today. All right. Example D. The square root of 28 over 7. Now we know that if we are square rooting a fraction, we can square root the top and bottom number of those fractions. Is 28 a perfect square? Tell them to go away, Shane. Oh, well, Christian, I don't know if I really want him. Leave me alone for 15 minutes, Ashlyn. Is 28 a perfect square? No, it's not. Thank you. The guy that's not even here can answer the question. Okay, it's not. 7's also not a perfect square, but does 28 over 7 simplify? What does it simplify to? Okay, so this is the same as square root 4 plus 2.4. What's the square root of 4? And 2 plus 2.4? 4.4. All right. Did an example of one of these already at the very beginning of your notes. Here's a couple more. Again, the reason we call it a square root is because it literally gives you the side length or the root of that square. And so if the area of this green square is 361, that means each side of that square is going to be how long? Jimmy? 19. Jimmy knows that 19 squared is 361. You know how I know Jimmy knows? Jimmy knows it's perfect squares. So the square root of 361 is 19. So each side length is 19 miles. 19 miles. Okay, it's probably Deacon, I assume. Example B, what if the area of the square is 4/9? What would the square root of 4/9 be, Christian? 2/3. Square root the top number, square root the bottom number, and that would be 2/3 feet, because once we're labeling side lengths, we're just labeling it in feet. All right, let's move to circles. We haven't seen these, but we know that the area formula of a circle has a square in it. So if I told you the area of this circle was 36 pi, remember the area formula for any circle is pi r squared. If they're giving you the pi, so it's in terms of pi, that means 36 is r squared. So if r squared is 36, what's r? Jimmy? 6. R would be 6 inches. Does that make sense? This is in terms of pi. So I'm able to identify that if 36 is being multiplied by pi, then 36 would be my r squared in this formula. And so square root 36 and you get 6. What about this one? The area of the circle is pi. Okay, so if the area formula is pi r squared, what does that make r squared equal to? Jacoby? 1. That's right, yeah. R squared must be 1. 1 times pi will give you the area. What is the square root of 1, Jacoby? 1. So the radius of the circle is 1. If you have a radius of 1, your circle will have an area of pi. Oh, 1 yard. I should probably label that like I labeled the rest of them. 1 yard. And we have 2 problems left. I thought I'd throw some interesting problems in this. Aliens, right? Yeah. Says the area of a crop circle is 45,216 feet squared. What is the circumference of the crop circle? So to go from area to circumference, what would I need to do? Xander, what would I need to do?
First do 45,216 divided by pi.
Okay, that's a good start. I'll come back to you in a second. So we know that the area formula, we just did a couple problems, can give us the radius, right? We know we can find the radius if we work backwards. So the first thing we would do, plug in 45,216. And Xander, you said divide by pi. Okay, let's just use 3.14 for pi instead of the pi button. For those of you who like to use the pi button, we'll just get the same answer this way. Xander, what is 45,216 divided by pi?
14,400.
Okay, so r squared is 14,400. Now, remember, I didn't have to do that in the last 2 problems because it was already in terms of pi. So we didn't have to divide by pi. If r squared is 14,400, then what do I do to find r, Garrett? That's exactly what I'm going to do. Can you find the square root of 14,400? $1,200. $1,200? Is that right? 1,200? We have one too many zeros. 120? Yeah. So say that I was trying to do it in my head and that just did not seem right. 120. So the radius of this circle is 120 feet. Now, how can I use that to find its circumference? Go ahead, Carter.
It'd be pi times diameter, so it'd be
Okay.
120 plus 100 plus
Okay, so do 120 times 2.
240.
240 is our diameter times pi.
Times
Go ahead and tell me what that is, Carter. That's exactly right. We find the diameter of the circle, which is be 240 then, times pi. And what do you get?
753.6.
All right, and that would be labeled in just feet, not feet squared, because it's just a distance around the circle. Once upon a time, we were finding circumference and area a lot, right? For our geometry unit that we did. All right, and then one more problem. You're putting a wire fence around your square garden. The area of your garden is 484 feet squared. The wire costs $3.50 per foot. How much would the fence cost you? Well, if I'm putting the wire around my square, can you get that, somebody? If I'm putting the wire around my square, thank you. Is that, what is that? What would I call that distance, Brady? Perimeter, exactly. And I need to know the side length.
Yeah.
So if the side
Yeah,
length of
just
that
kinda busy
square,
teaching right now.
see, 484. If the area of that square is 484, then what would the side length be?
Yeah, I can do that.
Carson can do it. Can you? Brady, go ahead. It would be the square root of 484. Do you know what that is? $22. So each side on the square is 22 feet. Oops, I put FF instead of FT. If each side on the square is 22 feet, what's the perimeter of the square? Awesome. Yeah, times that by 4. There's 4 22-foot sides. So we have a perimeter of 88 feet. And if the perimeter is 88 feet, that means we need 88 feet of fencing. And each foot of fencing costs $3.50. Now what do I do? Jacoby? And what do you get when you do that? 308 what? Dollars. Someone want to confirm that? Thumbs up? Excellent. All right, we are finished. Yes,
I said to the secretary, I'll just hurry when you're done, so you can make a test.
okay.